An introduction to programming, planning and brainstorming. So what I find is a big problem that people have in terms of programming is they don't understand the planning that's involved with it. And the planning and brainstorming aspect of any programming probably consists of 90% of the work. And once that is completed, then the actual programming can occur. And so there's a few pointers that I feel that I just need to emphasize on and go over so that you're aware of what is important and common mistakes that are made and how to go about when you've got a problem you've got to solve and there's some programming involved. Okay, so let me start off with the situation of this comic strip. So I've got this, I've heard this joke some time ago, and it is one that I always keep in mind, and I always explain it to people in terms of whenever I introduce some programming to try and get this point across and that I always will remember it. So the story goes when this guy heard that he can make a lot of money if he had to go to Saudi Arabia or one of those Arab countries. Because it's rich countries, you know, there's oil manufactured over there, and because there's a lot of money, he thought, okay, he's going to be one of those people that are going to go and make money. Anyway, so off he went, and just before he went, his friends asked him, well, listen here, you're saying that you're going to be making money over there, what are you going to be doing? And the guy says to them, well, you know what, I'm going to be selling Coca-Cola. Because you see, it is something that is drank over there. So in the Arab countries, they won't drink alcohol. So Coca-Cola would be considered an appropriate drink to drink. And so it will be able to be sold quite well and stuff. So this guy's friends asked him, well, you know, you say that this is the case, but can you speak Arabic? I mean, obviously, you need to communicate with the people if you want to market things and sell things and stuff. And the guy says, well, you know what, I actually do not need to know this, or I don't need to know how to speak the language. Pictures is your universal language. So he says he's going to have a comic strip very similar to this, where I got these pictures because for me, my stick figures are not going to be something that are going to be appreciated by you. Anyway, so you find a person lying down almost dead in a desert. He picks up a can of Coca-Cola and drinks it, and then after that he's revitalized and he's able to go for a jog. And they thought, oh well, okay, that sounds like a feasible solution. Anyway, so off he went to this Arab country, and about a month later he's back. And his friend spots him and sort of said, like, listen here, what's the story? You thought you were going to make a lot of money and stuff. And he says, like, yeah, no, that's what he thought, but he didn't understand things and, you know, it didn't work as planned. So they asked him, well, how many cans of Coke did you sell? So this guy says, well, actually he hasn't sold any. So they said, okay, well, tell us what went wrong, because, you know, obviously something must have gone wrong for you not to be able to sell anything. So the guy says, well, you see, with this comic strip, he thought it was going to work, and it would have been an appropriate sort of one to have. But he didn't realize at the time that in the Arab countries, they read from right to left. So the people were seeing a guy running around, drinking a can of Coca-Cola, and then after that, dead in a desert. Okay, so this sort of scenarios is something that I'm always trying to explain, because it's a common thing that happens where you find that people, when it comes to programming, they read from right to left. And now, I'm not saying there's anything wrong in terms of the Arab language reading from right to left, but when it comes to programming, the norm is to read from left to right. Okay, so to give you an example, where this is sort of something, or where I'm going with this, is that you'll often find that there's an expression in program that might be something similar to x is equal to x plus 1. Okay, so now it's a thing of this has to be interpreted. And what happens is people often will say, well, x plus 1 is equal to x. But they're reading from the right-hand side, and then they're going to the left-hand side because they say x plus 1 is equal to x. So when it comes to programming, you always have to keep on reading from the left-hand side to the right. So the correct way would be x is equal to x plus 1. So basically the new value of, so let's say x is equal to 5. X plus 1 is equal to, so x would be equal, so if x was equal to 5, it would be 5 plus 1, that would be 6, and that would be the new value stored in for x. Okay, so then basically it is the new value of x is equal to the current value of x plus 1. Okay, so keep that in mind. You're always reading from left-hand side to right-hand side. Okay, so that's the first point I want to make over here. The second point is that when it comes to planning, there's essentially two different ways of planning your code and or what steps you're going to be following. Okay, the one is known as flowcharts. Okay, so flowcharts uses basically it in a diagram format to sort of show what flow of the code would happen. So obviously, if you had to put this into something, so let's say for example you want to identify if a number is odd or even. Okay, so you'll have a start which will be represented by an oval shape. It will come down with an arrow. Then a user will have an input. So inputs are identified with a block in this shape. So it would be an input. Might be asking the user to enter a number. Number. So enter a number. Okay. Then after that, there would have to be some decision that would have to be made. And that would be something of, okay, so this is your decision. Decision. And that would indicate sort of, well, the question that you might ask over there is the number odd? If it is yes, then it would continue. If it is no, then it's got to go back and the user's got to enter again a number. So it's like checking to see if the number that the person has chosen is correct. Then there's some process that might happen. You might want to identify what's the number squared. You might want to maybe identify what odd number is it from 0. So there will be some process, some calculation involved. Okay, and after that's happened, then there will be obviously some answer that will be outputted, and that's also identified with the block as such. So that would be output. That might be the answer. And then from there it will go to an end, which is also represented as an oval shape. Okay, so this is a typical flowchart that you would come across. Nothing wrong with flowcharts. I'm not against them. Yet the issue is how do you expand on a flowchart? So for example, if once a person's entered in a number, there might be some calculation you might want to do and stuff. Or maybe after you've checked that it's an odd number, you realize, you know what, I should actually maybe first output some text over here to say, well done, you've entered in an odd number. But now how do I place an output box over here? It's going to get quite messy. So you don't know where to fit things in, and to expand your flowchart becomes difficult. So for that reason, that's the reason I'm against flowcharts. Also, the other way that you can do your planning is known as pseudocodes. Okay, pseudocode. Now, pseudocode, essentially it is a very rough, it doesn't have to be correct syntax, or if you had to, syntax would be essentially your grammar in programming. So the grammar does not have to be correct, but it looks at what steps you would follow. The thing is though, is once you've done your pseudocode, and I mean this is basically just plain language that you might have. Okay, so plain language. It could also be, some people go and use actually programming code directly. So you could represent it in different ways. The thing is with pseudocode is that once you've got your plain language or programming code in place, to translate that now into code would be almost like a copy and paste of what you've done in your pseudocode. While with a flowchart, you've got to still interpret those blocks into some specific code. Okay, so those are the two different ways that people go about with, or the two sort of common ways that people go about to plan for their programming. Now let's have a look at an example, and we'll be looking at flowcharts and pseudocodes at the same time, just to sort of see how it compares. Okay, and also explain why it is that I'm thinking the way I am. And so for that reason, I'm going to be showing you the different ways, and you know, it's fine, it's whichever way you want to use, but again, look at what I'm trying to say and explain, and then make a decision from there. And you'll probably also agree with me that pseudocode is the better way to go. Okay, so let's say we use the task. So you've got a pen that's in position 1 over here, and I want to move the pen from position 1, this will be known as, or from the left to the right. Okay, so that will be over there. What are the steps that I'm going to be doing? Okay, so if the pen's over here, and I want to move it from there to there. Alright, so in pseudocode, you would probably say something like start. That will be beginning. From there, you would go to the point of saying, okay, well, I want to pick up the pen, because that's the first thing we're going to do, pick up pen. Okay, so that will be some task to pick up pen. Then the next step is going to be, once you've picked it up, move pen to the right. Okay, so that's the next step we're going to be doing. Then after you've done that, then you're going to be like, put pen down. Okay, so you put pen down. Okay. And then once you've done that, that would be the end. Okay, so that's essentially the steps that you have to follow if you have to put it into a flowchart. Now I can say, how do you expand it? And you'll see now the reason why we're going to be expanding it. So if I had to do now pseudocode in using this very similar fashion. Okay, so first I'm going to say, okay, well, I'm going to obviously begin. Okay, once I've started the process, what do I need to do? Well, I need to pick up pen. Okay, right, so that's the first step. Then the second step I've got to do is, once I've picked it up, is move to the right. I say move pen to the right, but essentially it is move on to the right. Okay, now that I've done that, then I need to put pen down. Okay, so put pen down. And after I've done that, then it's the end. Okay, Now that is a general sort of task that we've done. That's like looking at the overall bigger picture of the different steps that had to be done. But picking up a pen, it consisted more of just going and picking it up. For me to pick up the pen, I actually need to place hand over pen. Then I need to close hand. Then, so that's already 2 tasks. Okay, so what does it mean to pick up pen? Well, I need to place hand over pen. Okay, now once I've done that, what is I had to grip pen. Okay, so grip pen. Then once I've done that, to pick up the pen, once I've gripped the pen, I need to move hand up. Okay, so then move hand up. Okay, so that's just picking up pen. Now let's look at move arm to the right. Okay, so I'm just going to say move arm to the right. That's going to be just my heading for that over there. Okay, so moving arm to the right, it doesn't just move. What do you have to do? Well, it's essentially your shoulder that's going to move. So shoulder move from left to right. Okay, so we've done that task. Put pen down. Okay, let's have a look at what that consists of. So putting the pen down, now we've moved to the right. So now I need to basically move hand down. Okay, so that will be move hand down. Now once I've moved the hand down, what do I need to do next? I need to release it. So open grip. And then once I've done that, then I need to move hand away. Okay, so as you can see, we've already expanded this over here quite significantly. Okay, so I'm just moving across over there like such, sorry. Okay, so I'm going to move this away because now if you look at this, if I need to say pick up pen, I'm going to break down all these tasks over here with that block over there. I don't really have space over here to expand on this. So I need to basically leave this as, it doesn't give me an option. I could possibly go and expand this block as well, but it can mean that you can move out of space. Also look at this in terms of the flow chart, how much space it actually takes on the page compared to me writing it out over there. It's a big difference in the amount of space needed. So I'm going to put the flow charts to the side so that you can just see what my pseudocode is and how I go about with that. Okay, so now that I've done this, placing the hand over the pen. Okay, so I mean that's something we will just assume as it is, placing the hand over the pen, and then it's a situation of grip pen. Okay, now gripping the pen, there's certain tasks that are involved over there. I mean, to grip the pen, it basically means the different joints in the fingers need to move inwards. Okay, so grip pen is actually going to be move finger joints to close. Okay, and I mean, if you take that into account, like, are you going to go and close your fingers over here and keep on closing it and keep on closing, even though you've gripped it and you've gripped it enough? You're going to keep on closing. Eventually, I mean, you don't have to grip it anymore. Once you know you've got enough grip, you can stop. Okay, so you can say, well, continue gripping. Okay, and then you could have some decision over there. Okay, so again, what I'm going to do is this part over here, I'm just going to come and bring it down over here so it's easier to follow. So grip pen. Okay, so grip pen, we said move finger joints or fingers joints to close, and then we're going to say continue closing. But obviously once we get to a certain point we don't need to close anymore. Okay, so we're going to say, okay, continue closing, And then we're going to have a condition over here maybe. Is grip on finger enough to prevent slippage? If it is yes, then continue. If it is no, well, obviously it needs to go back and continue closing. So we've got something that's going to keep on happening over here in a continuous manner until a certain condition is met, where it is good enough to, to prevent slippage. Okay, then we've got a situation of where we had moving a hand up and down. Okay, so moving hand up and moving hand down, those aren't things that just automatically happen. Okay, so moving hand up would actually mean moving elbow up, and moving hand down will actually mean moving elbow down. Now you can be technical and say, well, moving the elbow up and moving the elbow down, it's not as such a, it doesn't happen automatically. It might mean that you need to induce muscle X, and you need to maybe induce muscle Y. While moving down, you might need to say, okay, well, I'm going to need to induce muscle, let's say X as well, and you might need to induce muscle Z. Okay, so the thing is you need to expand on every single task that there is until you get to the very basics. In this case, if it was biology, it would be the actual initiation of different muscles. And that all comes from just the basic principle of picking up pen, move arm to the right, put down pen. So that's what you need to do in programming. Whenever you get a problem, look at the overall view of what you're going to do, and then break it up into smaller pieces. Each point, break it up into the next sort of set of broken down pieces, and then take each of those broken down pieces and break it down even further. And in this way, you're able to do, sort of get the overall picture of what steps need to be taken. So now I can basically, when I have to write my final code, I basically just go and say, okay, well, I can write begin, wherever I'm going to start my code. I get to this step over here where it says pick up pen, and I say, okay, well, first I'm going to place hand over pen. Do I have anything over here that says over here how to place hand over pen? No. Well, we did say it meant actually moving the arm to the right, or basically, or in this case would be moving the arm to the left and lowering the elbow. So we could say, okay, well, that means moving elbow down. Okay, so we can basically place these steps over here of inducing muscle X and muscle Z, we can place it over there for placing hand over pen. Then we must say, okay, we need to grip the pen. So it means that we need to move finger joints to close. And what did we say that the finger, for that to happen, we need to basically perform these steps over here. So we can write down these steps as it is over there. Then we go to the next step. Okay, that means we need to continue gripping? Okay, we've done that. We've looked at that condition over here. And then we need to move hand up. And moving hand up means moving elbow up. So we're actually going to induce muscle X, and therefore induce muscle Y. Then we're going to go from there to moving arm to the right. And again, as I said, moving arm to the right was shoulder move from left to right. So you're able to jot it down, even though you've broken it up and expanded on it, you're able to bring it together into step by step of what needs to be performed. And for that reason, that's the reason I actually like the pseudocode approach, because you can expand on it and stuff, and you almost have everything in place. You just need to basically bring it together, and once you have it together, you're able to generate your final code. Okay, so now that we've looked at the different types of ways of planning, what I need to go over with you is the basic steps that you need to follow. So there's around about 5 steps that you need to do whenever you've got a program to write or some problem to solve. Okay, so the steps you need to take are going to be the following. So firstly, you're going to brainstorm the problem. Okay, so brainstorm problem. And let's say, for example, I say to you, well, write a piece of code that's going to generate the following set of numbers. And it might be 1, 2, 3, 5, 8, 13, 21, 34. Okay, so now you get all these numbers. Where do they fit in? You can't really sort of see how they fit in. Okay, and so to be able to overcome that, what you're going to have to do is you're going to have to sort of look at it and first think, okay, how do these numbers fit together? So you look at the numbers and you're like, okay, well, 1 and 2, I don't know what that means. Maybe it's got something to do with at squaring a previous number. So if that was 2 squared, it would be 4. No, so that doesn't mean that doesn't allow the sequence to be generated. Then you might say, okay, well, let me have a look at the other numbers later on and sort of try and figure out over there. And you look at the problem and you sort of, okay, well, maybe it's a multiplication of the number. So 1 times 2 is not equal to 3 though. Maybe it's 1 times 2 plus 1 is equal to 3. Well, that could maybe work. Let's look at if it works with the next number. 2 times 3 is 6 plus 2 is 8. But there's a 5 over here. We do have an 8 over here, but there's a 5 over here. So that doesn't make sense. So then you go and look at it and you like realize, oh, okay, you can see a pattern happening where this 1 plus 2 is equal to 3. 2 plus 3 is equal to 5. 3 plus 5 is equal to 8. 5 plus 8 is equal to 13. 8 plus 13 is equal to 21. Oh, okay, now we've figured out what the pattern is. Now that you've brainstormed it, and you can say, okay, well, putting this into, and I mean, this typical way that you would then go about with writing it. You would then say, okay, well, 3 is equal to 2 plus 1. 5 is equal to 2 plus, so 3 plus 2. 8 is equal to 5 plus 3. 13 is equal to 8 plus 5. Okay, so now we've got some pattern, some formula that we're looking at. Okay, now it becomes the thing, okay, now that we've done it, we need to do the next step, which is generate some algorithm. Now, generating this algorithm can be done in different ways. The thing is, though, I mean, it could be maybe multiple algorithms that you need to perform, which is fine. I mean, sometimes it might be a single algorithm. Sometimes it could be numerous algorithms that need to be done to be able to get that happening. Okay, so we looked at this, and essentially we saw that with this, value n is equal to value n of minus 1 plus the value of n minus 2. And essentially what you've put into the way that you calculate this in your mind, now you put into some algorithm that you can put onto paper. Maybe it was something where you had to, before you come to this algorithm, you've actually got to say, well, oh, you know what, 8 is equal to 5 plus 3, so that's the previous number plus the previous number. You might need to say, okay, you know what, maybe what is value of n minus 1? I mean, that it's not something you can necessarily place into some specific format. So I need to maybe say, well, this is equal to previous number plus the previous number. Previous number. Okay, so you need to maybe break it down, and obviously it depends on how it comes to your programming, because your programming does use different terms. You might need to use terminology that's in your programming to come and generate this. But also, when you look at this, when I say 3 is equal to 1 plus 2, what do I need to do then? Well, after I've done this, I need to then say, okay, output Vn, and then Vn is going to have to, or the value of n is going to be the next one, so we need to increment n, so n is equal to n plus 1. Because in other words, if we were calculating the value of 3, which is equal to 1 plus 2, now we've got to calculate the value of 5. So we need to increment in to become that position over there. And that's going to be then equal to 2 plus 3. But once we've done that, and we get to position 5, what do we have to do? So again, let's just go through these step by step. So value of n, which will be, let's say this position 3 over here, is equal to the previous number plus the previous number. So that's 3 is equal to 2 plus 1. Okay, now we output the value of it. So 2 plus 1 is equal to 3. We get the value of 3. Now we get to the next value. But this value is equal to, we know in our mind it's equal to 3 plus 2. But that is then this step over here that we need to do. So we need to repeat these steps again. So we're going to have to come back and keep on looping and repeating this algorithm to be able to generate all the numbers. But the thing is you can go also onto infinity. Maybe you need to stop at a number. So we can maybe say, well, in this case we've got 8 numbers. Maybe your problem states, well, you need to stop at the value 8. Okay, so we're able to say, okay, well, if you stop at value 8, that means that we need to say, well, repeat this, but only if n is less than or equal to 8. Then we repeat it. If not, then it needs to stop. Okay, so we can then say stop over here. Okay, so that's just pretty much in sort of the process that I've got to then follow. I've just basically placed the process that's been going in my mind to generate these numbers. I've put down onto paper. Okay, now that I've done that, the next step we need to do is we need to draft or generate some rough code. Okay, and essentially, this would be essentially a pseudocode, as I was mentioning before. So essentially you're going to use this algorithm we've got over there. We're going to be writing some code over there. So it might be something like, okay, begin. Then we might say, okay, value n is equal to value of n minus 1 plus value of n minus 2. Okay, and then we're going to output n, or output vn, and we're going to say, well, n is equal to n plus 1, and then we're going to say, well, if n is less than or equal to 8, then it needs to go, sorry, not to the beginning, but needs to go over there, and then stop, okay, or end your program. The problem comes in now, and that's the reason for the rough code, is when it comes to your final code, there needs to be very little error in it. I mean, if I mark any code, and I realize that there's a whole bunch of little asterisks, and so there's a star over there, and then I get to somewhere else, a star A and a star B, and then, later in the code, it gets indicated what these values are and what you forgot and stuff. It confuses me, and I basically don't give you any marks for it. So you want to prevent any confusion from happening. So we don't want these asterisks and indication of lines of code here and there and stuff. Because if you look at this code, something we've forgotten to indicate over here is what is the value of vn minus 1 and what's the value of vn minus 2. We actually need to say over here, well, star, and I'm going to write it over here. So star, we need to say, well, vn minus 1 is equal to 2 and vn minus 2 is equal to 1. Okay, so now we've actually indicated what it is. This needs to this piece of code over here needs to go in after the begin, but before where the looping is going to be happening. Okay, but then also what we've forgotten to do is when we go to n is equal to n plus 1, these vn minus 1 is always going to be 2 and vn minus 2 is always going to be 1. We need to now give them new values. So after we say n is equal to n plus 1, we actually need to say, well, now, okay, therefore, as a matter of fact, vn, so we'll have over here maybe double star, and we'll say at double star, We're going to say, okay, well, Vn we need to then go and say, okay, well, now Vn minus 1 is equal to Vn, okay, and Vn minus 2 is equal to Vn minus 1. So we need to place this code over here. So now when you go and you do your final code, you're able to sort of see it, write it out very neatly and correctly. Then after we've done our rough code, we need to test variables. Okay, and that is where you basically will go and sort of draw a margin on the right hand side, and you would actually monitor what the variables is that you've got. So in this case, we've got Vn minus 1, or we've got Vn minus 1, and Vn minus 2. Okay, so when we start off, we indicated that Vn minus 1 is equal to 2. We indicated Vn minus 2 is equal to 1. Okay, so now we're going to go through our code and see if the values are updating as correctly and in the way that we want it to happen. Okay, so Vn is equal to Vn minus 1 plus Vn minus 2. Okay, so Vn is equal to 3. Okay, so we are able to say over here, now Vn is equal to 3. Okay, output Vn, so that will go to some screen on your computer. N is equal to n plus 1. Okay, so now we've got to say, well, over here we've initially said that n might be equal to 3 because we're starting off with the third number. So therefore that means that now if we say n is equal to n plus 1, n is equal to 4. Okay, is n less than or equal to 8? Yes, it is. Okay, so now it's going to loop back and we're going to do this again. So now Vn is equal to Vn is equal to Vn minus 1. But before I do that, I forgot about these two asterisks over here. I need to do this code over here first. Okay, so before I go to if n is less than or equal to 8, Vn minus 1 is now equal to Vn. Okay, so Vn minus 1 is now equal to 3, and Vn minus 2 is equal to Vn minus 1. Okay, so now it's going to be, okay, Vn minus 1 is equal to 3, but we want equal to 2. We can't have that equal to that. So now we see the order of this is important. We actually need to first say Vn of minus 2 is equal to Vn minus 1, and then say Vn minus 1 is equal to Vn. So if we swap that around, let's cross out this last change in variables and see if that works. Okay, so first we're going to say Vn minus 2 is equal to Vn minus 1. Scratch that out over there, see if that order works. Okay, so now we're going to say Vn minus 2 is equal to Vn minus 1. So Vn minus 2, this new variable is equal to 2. Vn minus 1 is equal to Vn. So Vn minus 1 is now equal to Vn, which is 3. Okay, that is now correct. That seems to follow the process that we're wanting to do. Okay, now that we've done it, if is n less than or equal to 8? Yes, it is. N is equal to 4. So let's go back to the beginning. Okay, now Vn is equal to Vn minus 1 plus Vn minus 2. So that is equal to 3 plus 2. So that now Vn is equal to 5. Okay, that makes sense. We are going to output it. Then we're going to say, okay, well, n is equal to n plus 1. So now n is equal to 5. And then we come over here, okay, and Vn minus 2 is equal to Vn minus 1. Okay, so that means that this new value over here is now equal to 3. Okay, so that would be equal to 3 instead of 2. Vn minus 1 is equal to Vn. So Vn is equal to 5, so that means Vn minus 1 is equal to 5. Okay, now that we've done that, we can check is n less than or equal to 8. Yes, it is. It's equal to 5, so we can go back and repeat this process. And you actually update all the variables as you go along. As you saw, it was critical that the one line came before the next line. So in this way, we're able to see if our code is correct. So it's important to test variables. Once you've tested your variables and you know your final code is correct, then you're going to write final code. And essentially what that's going to consist of is taking your draft, your pseudocode that you've done so far, and you're going to go and copy it across. Okay, so it's going to be almost 5 minutes or 10 minutes of your time to copy the code across to what you've got. Once you've done that, then you need to put in comments. And the comments will allow you to indicate in terms of what steps have to be, at least what was going through your mind, why you are doing certain steps, why it is that you are going a certain way or a certain fashion, or maybe a certain algorithm that you're implementing. Maybe what is the algorithm? So your final code needs to have comments in it, because essentially another programmer needs to be able to look at your code and sort of identify what you're trying to do. They need to get into your mind, see what you're trying to do. Okay, so it's important to then add your comments over here. An example of how to go about with these different steps to solve a problem in programming is shown in the 8th video of this video series. And this essentially will give you an introduction to that, and will start becoming clear, especially once you've started getting familiar with programming. Once you got familiar with different codes and different syntax, a lot of this will become more clear to you. But make sure that whenever you get a problem, follow these steps. As a matter of fact, for me, whenever I've got to do any marking, I actually give marks for these different steps. So if you have a brainstorming problem, indicate how you went about with it. Show maybe what calculations you had to do. Okay, now that you've done it, then show what your algorithm is. What sort of steps have to be taken roughly in terms of what you've now just brainstormed and seen a solution and implemented and placed it on paper. Then once you've done that, then go and generate your rough code. Once you've got your rough code and steps down, go and test it out. Test all the variables. Like I've done over here on the right hand side, I have a margin, and actually go and keep record and track of the different values. Once you know everything is working and working correctly as you've planned, then go to writing your final code and doing your comments. Like I say, when you look at the examples, things will become more clear, but these are critical steps that you need to follow. So make sure that you follow these steps whenever you're brainstorming or trying to solve and write code for a specific problem. And I know that a lot of people are very familiar with programming, and they often think this is a waste of time. The problem is very straightforward. They can just go and start typing it out on code. And yes, I'm not saying that that is not possible, but those problems that they are having to solve are very small problems. I've come across to having problems that have been so complex that I've been writing small letters of text, of actual code, and that has been my pseudocode. And I mean, the text letters was probably about 2 millimeters in height, and this covered a whole A1 sheet of paper. So it can become then complex, and you see these parts that need to be repeated maybe, and these parts that, as you go and you write it out and you try and sort of plan it out, you might see that this might be an error that you've made or something you've forgotten to declare before. So it just helps with planning and seeing an overview in front of you than having to scroll up and down on a screen and not seeing the whole picture of what is happening. Also make sure, as I mentioned, that you go and have a look at things like your beginning of code, in terms of breaking it up from a big picture to a smaller picture, as we've done over here. And essentially, this is what we've done. We had brainstormed the problem. We identified an algorithm, which we broke that one up into smaller steps, or into more steps. And in that, we went and broke even down to further steps when we generated our draft code. And then finally, make sure that you always remember to follow the steps over here of always reading from left to right, or from the top to the bottom, and not making the mistake of reading from right to left or from the bottom upwards.